Mars has long intrigued scientists as a potential cradle for extraterrestrial life. Its dusty red surface, frozen poles, and ancient riverbeds all hint at a complex and dynamic past. But a new discovery has brought the red planet back into the spotlight. Scientists have detected mysterious organic molecules on the surface of Mars. These compounds, found by NASA's Perseverance rover, could hold clues to ancient Martian life or complex chemistry. The term organic molecules refers to compounds that contain carbon, the chemical backbone of life as we know it. However, their presence alone does not confirm the existence of life. Organic molecules can be formed through both biological and non-biological processes. Nonetheless, their discovery is a major milestone in astrobiology. Perseverance detected the molecules using a sophisticated instrument called SHERLOC. SHERLOC, short for Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals, uses ultraviolet lasers to identify chemical compounds. It found signs of organic matter in Martian rock samples collected from an ancient river delta in Jezero crater. This crater is believed to have once hosted a large lake, making it a prime location in the search for past life. The molecules were located in sedimentary rocks, which are often formed in water-rich environments. These rocks also contain sulfate minerals, which can preserve organic matter over long periods. The specific structure of the molecules has yet to be fully identified. However, they resemble types of compounds that on Earth are associated with biological processes. Scientists are being cautious, acknowledging multiple possible origins. The molecules could be remnants of ancient microbial life. They could also be the result of abiotic chemical reactions between rock and water. Or they might have been delivered to Mars via meteorites. Regardless of origin, the find suggests that Mars once had conditions suitable for complex organic chemistry. This supports the hypothesis that the planet may have been habitable billions of years ago. The fact that these compounds were preserved for so long is equally significant. It indicates that Mars may have pockets of preservation, areas where signs of life could remain intact. Understanding how these molecules formed and survived will be key to determining Mars' biological potential. Future missions aim to bring these rock samples back to Earth. NASA and the European Space Agency are planning the Mars Sample Return mission. This initiative will retrieve core samples collected by Perseverance and analyze them with advanced laboratory equipment. Earth-based analysis will allow for more precise measurements and deeper chemical studies. If biosignatures, chemical signs of life, are found, it would revolutionize our understanding of life in the universe. The discovery has already energized the scientific community. It adds to a growing body of evidence that Mars was once a watery, potentially habitable world. Previous missions like Curiosity and Viking also hinted at organic molecules and favorable conditions. But the latest findings are more detailed and located in a context-rich environment. The river delta where the molecules were found is analogous to deltas on Earth, where life is abundant. Sediment in such regions traps and protects organic material, making them ideal for fossil preservation. Perseverance's ability to detect these signatures confirms the effectiveness of its scientific instruments. The discovery also raises the question, if organic molecules exist on Mars, might they exist elsewhere in the solar system? Moons like Europa and Enceladus, which have subsurface oceans, are considered strong candidates. The detection of organic molecules on Mars increases the likelihood that life-supporting chemistry is common in the cosmos. It also supports the panspermia hypothesis, the idea that life, or its building blocks, can travel between planets. Meteorite impacts could have spread organic material throughout the solar system. Could Earth and Mars have exchanged biological material in the distant past? If so, the story of life might not be confined to one planet. It might be a shared narrative across worlds. Further research will focus on identifying the molecular structures in greater detail. Scientists hope to distinguish between biotic and abiotic signatures. They will also look for patterns in where these molecules are found, which might reveal ancient microbial ecosystems. This breakthrough strengthens the case for continued Mars exploration. It also underscores the importance of interdisciplinary science, combining geology, chemistry, and biology. NASA plans to deploy even more advanced instruments on future missions. As technology improves, so too does our ability to answer fundamental questions. Are we alone? Did life ever exist on Mars? Could it still exist underground, shielded from radiation and surface extremes? These are the questions that keep scientists searching, exploring, and dreaming. The discovery of mysterious organic molecules on Mars is not the final answer. But it is a powerful clue, one that points toward a more complex and potentially life-friendly Martian history. As we continue to study the Red Planet, we may be drawing closer to answering one of humanity's oldest questions: are we the only life in the universe?